So here we can say that new topic of discussion what I'm thinking is differentiation, that differentiation as a slope of a tangent to a curve. In calculus, the derivative is a measure of how a function changes as its input changes. In general, a derivative can be thought of as how much one quantity is changing in response to the change in some other quantity when these two quantities are related by some relation. To understand the concept of differentiation, let us start with the simplest case when y is linear function of x, that is y is equal to fx mx plus c, where m is the slope of the function. Now consider 2 points a x comma fx and b x plus delta x f x plus delta x on the line where f x plus delta x is equal to y plus delta y and fy is equal to fx is equal to y. So in this Cartesian system, what we can say is a straight line y is equal to mx plus c is passing by. So the change in y, that is delta y, respect to change in x, that is delta x constant m, which is slope, which is slope, which is the slope, which is slope the line, which is slope of the line, which is slope, which is slope of the line. So for any 2 points A and B on the line, delta y by delta x is equal to f function of x plus delta x minus fx by delta x is equal to m. If delta x tends to 0, points A and B are very close, but ratio is a constant. We can say that slope of the line is same for any segment of the line selected. Now consider the function y is equal to fx, the graph of which is not a straight line. Consider the function y is equal to fx, the graph of which is not a straight line. Line segments joining different pair of points A and B on the graph has different slopes. Line segments joining different pair of points A and B has different slopes. Consider one such line segment AB having endpoints on the curve. Suppose we want to find the slope of the curve at point A. Slope of the curve at point A is same as the slope of the tangent to the curve at point A. Slope of the curve at point A is same as the slope of the tangent to the curve point A. Now we consider tangent is A as chord, where it's chord AB when point B is very close to, because the length of chord AB is infinitely small. For that we drag point B on the curve towards A. That means we are lowering the values of delta x by making delta x infinitely small when delta x tends to 0, chord AB behaves as tangent to curve at point A. So, by making delta x infinitely small, that is delta x tends to 0, chord AB behaves as tangent to the curve at point A. Chord AB behaves as tangent to the curve at point A. D of fx means very small change in the very small change is value of fx produced by very small change dx, the value of x, and theta is the angle of tangent at point A to the curve with positive x-axis. The ratio d fx d of fx by dx is called derivative of x with respect to x, which is same as slope of tangent to the curve at point A. Ratio d of fx by dx is equal to d by dx of, so d of the ratio d of fx by dx is equal to d by dx of fx, is also called differential coefficient. Derivative of fx with respect to x is also written as f dash x and read as f prime of x. F prime. Okay. If above graph of the function is considered as graph of the displacements versus time, then it represents functions s is equal to ft. Okay. So d by dx of a constant as derivative is change in value of y with respect to x, but in constant function, if input x is changed, the value of y does not change, the derivative is 0. D by dx of sine x is cos x, cos x is minus sine x, of tan x is sec square x, cot x is minus cos x square x, sec x is sec x tan x, cos x is minus cos x cosec x, cot x, x to the power n is nx to the power n minus 1, e to the power x is e to the power x, log e to the base e, e to the power x is e to the power x, log modulus of x to the base e is 1 by x, sine inverse x is 1 by under root of 1 minus x square, cos inverse x is minus 1 by under root of 1 minus x square, tan inverse x is 1 by 1 plus x square, cot inverse x is 1 minus 1 by 1 plus x square, sec inverse x is 1 by modulus of x into under root of x square minus 1. D by dx of cosec inverse x is equal to minus 1 by modulus of x under root of x square minus 1. So let us try the first question now. We have seen there are 16 uh, derivatives. Okay, so let us try some questions from differentiation. If the y is equal to this and x belongs to 0 pi by 2 union pi by 2 and pi, and we need to find here dy by dx. So we have y is equal to under root of 1 minus cos 2x upon this, and x belongs to 0 comma pi by 2 union of pi by 2 comma pi. Find dy by dx. That is the question. Okay. So how to start this question? dy dx we require, and here x belongs to 0 to pi by 2, 0 comma pi by 2, union of pi by 2 comma pi, that is the means 0 to 90 degree and 90 degree to 180. It's a union of this two. So we know some simplifications, so we can utilize some simplification, that is fine. 1 minus cos 2x on 1 plus cos 2x. So 1 minus cos 2x is 2. So this can be easily converted to some other form. Let us see how. Y is equal to 1 minus cos 2, so it is with 2 sine square x upon 2 cos square x, or this will be tan x. Y will be equal to tan x, and 0 to pi by 2. Now we are looking after modulus of tan x. Okay, that obviously it is modulus of tan x, and x here belongs to 0 pi by 2 union pi by 2 pi. So dy by dx of tan x is sec square x. 0 to pi by 2 is positive, and pi by 2 to pi. 0 to pi by 2, pi by 2 to pi, we have an increasing function. So union of these two is there. Obviously it will have two values. It's very sure with us. Y will be equal to tan x. X belongs to 0 comma pi by 2 and minus tan x x belongs to pi by 2 to pi. Because modulus is there, we'll have two values. So that is clear with us. That is tan x 0 to pi by 2. 0 to pi by 2 we have tan x is positive, and pi by 2 to pi we have from negative it is starting. So minus tan x will be there. So that looks to be certain, but I will refer the 2.4 of trigonometry also as mentioned. So in tan 0 to pi by 2 we have increasing function positive, and pi by 2 to pi we have negative or decreasing function. So it will have two type of conditions here. That is very sure with us. Okay. So one of the conditions will be tan x will be there, and pi by 2 to pi we have negative. Therefore we can say dy by dx, in this case it will be we know it is sec square x. Sec square x, x belongs to 0 to pi by 2, and negative of sec square x, x belongs to pi by 2 to pi. In case of trigonometry, let us see this one also. So negative it is there. So this can be understood like this. Okay. Using the first principle. Okay. f dash root 3 using the first principle. Fx is given, some function is given, then f dash x is limit of h tends to 0 fx plus h minus fx upon h. Okay, so these questions I need to think of. Derivative. Okay, so